Okey dokey, up and running. Let's pull this. All right, so I'm gonna start a 5 rep series. You've just started tackling these problems in class and wondering what the heck's going on. So I'll talk about it briefly at the end. Right now, it's just gonna be 5 reps. We're gonna get a little practice in. That's how you get better at anything, you practice. And so we'll get that started, and then every day it'll be on a worksheet. And you got 3-4 months of practice. I would assume you'd be able to master this topic, the mechanics of it. All right, so x minus 2 times what? Equals x squared minus 8x plus 11. I'll put it here. X minus 2 times what? Equals, and we'll do it 2 ways here. Let's make this a bigger parentheses. And let's put, we'll talk about why we're doing this later. And right now, we'll talk just the mechanics. X squared minus 8x plus 11. Now, the nice thing here is I got the marker. I get to write what's true. I'm going to write this calculation in a different manner. Now, there's only one way that I can get x squared minus 8x, and that's x minus 6. Right? I really no need to even do that right now. X times x is x squared minus 2x. I gotta get to minus 8x. Minus 6 times x gets me minus 6x. And now I have the first 2 terms. What I don't have is the last term. And right now, minus 2 times minus 6 is positive 12. And I gotta get to 11. I gotta take 1 away. But I would hope that with practice, you could see that you could put it in the parentheses as minus 1 over x minus 2, because that is a skill of conversion. Multiplying by x minus 2 and dividing by x minus 2 cancels, and the positive 12 gets dropped down by 1 and becomes 11. Now, a nice thing about putting it outside the parentheses is you can see some pretty nice numbers here, 2 and 6. And you can see what happens when you put a 2 in or a 6 in. It comes out as a y value of -1. Now, if these are actually the same equation, the same function, the same calculation, then those same table values should appear here. X and Y. I'll use a 2 and a 6. I put in a 2, I get 4 minus 16 plus 11. That's 15. Take away 16 from 15, -1. Oh, I get the same answer. And if I put a 6 in, I should also. 36 minus 48, which is minus 12, plus 11, is also -1. They're the same calculation. Okay. And my reasoning for doing this is people finish algebra 1, they do long division, they might even do synthetic division. I don't do it anymore. I don't see the purpose for it. Yeah, I'm sure that historically it's got relevance, but the long division is something that students do at algebra 1 and wonder why. After we practice, I'll show you why. And hopefully this is a segue into understanding why you were doing something like that a year or so ago. All right, so I need an eraser. What else is new? Maybe one of these days I'll actually have it before I start a video. All right, so this is the way to check using some friendly numbers, seeing what you get, putting those friendly numbers into the other way of writing the calculation, and seeing if you get the remainder. And if you don't, you've made a mistake. And it would also be nice for you to think about why you can write it this way. Because when you get rid of the x minus 6, the x minus 2's cancel, and you adjust the constant to what you need it to be. All right, so now we're going to practice 4 more. We're even going to finish with a cubic. Next one. X plus 3 times what? Equals x squared plus 9x minus 5. Now you're trying it. You're stopping the video and you're giving it a go. I'm just gonna do it real quick. I need an x to get x squared, positive 3 to get to 9, I need a plus 6 to get to 9x. Right now, 6 times 3 is 18. 18, I gotta get to minus 5. I can either put the remainder of minus 23 outside, or I can move it inside and divide by x plus 3. And that is my answer. So if I multiply this times this, I should get that. I have a remainder of minus 23. I want to make sure I didn't make a careless error. I know my friendly number is minus 3. And I want to see if I put a minus 3 in here, see if it comes out as minus 23. So that's 9 minus 27 minus 5, which is minus 18 minus 5, which is minus 23. I can move on. All right. X minus 4 times what? Gets us x squared plus 20x minus 3. See if you can do it. Pause. I'm pausing. You're pausing the video. I'm just going to do it. So I need an x. Right now I have minus 4x. I got to get to 20. I guess I better add 24 x's. And that's where I get the 24x right there. 24x minus 4x is 20x. So far, so good. And now I've got minus 4 times 24, which is minus 96. I got to get to minus 3. I got to add 93 over x minus 4. How do I know if it's right? I look at the friendly number, 4. I'll put that 4 in here and get 16 plus 80 minus 3. I do believe 96 minus 3 is positive 93. I'm moving on. Right. Next, x plus 2 times what? Equals x squared minus 5x plus 7. I need an x to get x squared. I need minus 5x. Well, I got 2 right now. I better go down 7 x's. Yeah, that definitely gives me the first 2 terms. But now I've got minus 14, and I got to get to 7. Well, I better add 21 over x plus 2. What's the friendly number? Negative 2 should get me a remainder of 21, especially if I put the 21 outside the parentheses. So negative 2 squared is 4. Negative 2 times minus 5 is positive 10. 14 plus 7, 21. I'm moving on. Okay, now, it's quicker just to write your answer than it is to do the Algebra 1 textbook. X squared plus 20x minus 3. Let's put that x in a better position. Okay, and what you learned a year or so ago was to put x into x squared, x times, it goes x times. Now, this is one place where changing the sign and adding is a very nice thing. For instance, 7 minus 3 is 4. So is 7 plus a minus 3. I'm going to use this mechanics in this long division problem, and I'm doing a column at a time. X times x is x squared, positive x squared. I'm going to make it negative and add. Cancels the column. X times minus 4 is minus 4x. I'm going to change the sign and add 24x minus 3. How many times is x going to 24x? 24 times. 24 times x, 24x positive. I'm going to make it negative and add. 24 times minus 4 is minus 96. I think I'm going to change the sign and add. And there's a remainder of 93. And I trust that's what we got when we did it just by working horizontally left to right. All right, so these are placeholders. That's what long division is all about, is if you're not strong enough computationally for a level of difficulty problems like this, I don't think you need placeholders for these. All right, and why do I say that? because when you get to calculus and you have to integrate something like this, students don't have a problem with the calculus, but they can't say this is the integral of x minus 3 minus 6. That's 18. How do I get from 18 to 7? I gotta add 25 over x minus 3 dx. And anybody who studied calculus, you know, past midterm level, knows that that integration is x squared over 2 minus 6x plus 25 times the ln of the absolute value of x minus 3 plus c. And folks don't get that line of work wrong. But the foundation necessary to get here is what's lacking. That is what I have seen. So when I see a foundational weakness in calculus, then at the earlier levels, I want to correct it. All right, let's do the cubic. And of course, what comes out of this eventually synthetic division, historically, right? Somebody sees the patterns and what, you know, I don't even need to write the letters. I can just work right across and put the numbers down, and that used to be a way of computing many years ago. All right, so x minus 3 times what? I think I can do it right here. So x minus 3 times what gets me x cubed? Well, x squared. Well, now I have minus 3x squared. I need minus 4x squared. So I need a minus x, because minus x times x is minus x squared. And minus 3x squared is minus 4x squared. And now I have minus 3 times minus x, which is positive 3x. I don't want 3x, I want 7. I better add another 4 x's. Okay? And of course, now I got minus 12, and I don't want minus 12. I want minus 1, so I better add 11 over x minus 3. And what's the friendly number? 3. So let's see if 3 gets us 11. 3 cubed, 27, 9 times negative 4, negative 36. Let's do that right away. That is negative 11. Let's put a 3 in here. That's 21. Let's do it right away. 21 minus 11 is 10. And I think I made a mistake. 10 minus 1 is 9. Let me check again. And if I did make a mistake, that's how I catch it. So it's useful to do it. So let's check this because I'm talking. X squared, that's good. Minus 3x squared, another minus x squared, minus 4x squared. Okay, now I'm at minus 3 times minus 4 is minus 12. And how do I get from minus 12 to minus 1 at 11? I think I did that right. So let's put this in again and do this computation. 27. As I don't want to have to do this video again. Minus 36, so 27 minus 36. 7 times 3 is plus 21 and minus 1. So 27 and 21, let's do that. 48 minus 36 minus 1. 48 minus 36 is 12. 12 minus 1 is 11. Okay, so my check, I made a mistake with the mental math there a minute ago. They match up, so I don't have to do the video again. How nice. All right, now obviously this is going to take a little bit of practice for you. I think I've probably done 100,000 of these. All right, so I got a lot of reps in. Yeah, that's how you get better at things, reps. So don't waste your time in class. Keep doing problems, keep doing problems, keep doing problems. All right, so there's that skill. I don't know how long this video took, but we'll find out. Ta-ta.